According to the National Electrical Code, or NEC, the installation of set screw couplings is not permitted for use in concrete encased raceways according to NEC section 358.12. This restriction applies to any type of conduit, including half-inch EMT. Set screw couplings are designed to create a temporary connection between two conduit ends, allowing for future adjustments or modifications. However, when embedded in concrete, these couplings can become compromised due to pressure and moisture, which can lead to electrical hazards. Therefore, in areas where concrete will be added, you must use a more permanent coupling method, such as threaded couplings or compression couplings. These couplings provide a secure and durable connection that can withstand the stresses associated with concrete encasement. When working with electrical conduit and raceways, it's essential to adhere to the National Electrical Code, or NEC, guidelines to ensure safety and compliance. The NEC provides specific requirements for the types of couplings and connectors that can be used in various applications, including those involving concrete encasement. The primary reason set screw couplings are prohibited in concrete is their susceptibility to corrosion and loosening over time. Concrete is a porous material that can absorb moisture, and this moisture can penetrate the set screw coupling, leading to rust and degradation. Furthermore, the expansion and contraction of concrete due to temperature changes can exert pressure on the coupling, potentially causing the set screws to loosen. A loose or corroded set screw coupling can compromise the electrical continuity of the raceway system, creating a potential safety hazard. It can also lead to ground faults, short circuits, and other electrical problems. In contrast, threaded couplings and compression couplings are designed to provide a more robust and watertight connection. Threaded couplings are joined by screwing two conduit ends together, creating a secure mechanical and electrical connection. Compression couplings use a compression ring to tightly grip the conduit, forming a seal that prevents moisture from entering the raceway. These types of couplings are less likely to corrode or loosen when embedded in concrete, making them a safer and more reliable choice. When installing electrical conduit in concrete, it's crucial to select the appropriate type of coupling and to follow the manufacturer's instructions carefully. The NEC also provides guidelines for the proper spacing and support of conduit runs in concrete. By adhering to these guidelines, you can ensure that the raceway system is properly protected and that it will function safely and reliably for years to come. Always consult the latest edition of the NEC and any applicable local codes before beginning any electrical work. If you are not familiar with electrical codes and practices, it's best to hire a qualified electrician to perform the installation. This will help ensure that the work is done safely and in compliance with all applicable regulations. To further elaborate, let's delve into the specifics of NEC section 358.12, which explicitly prohibits the use of set screw couplings in concrete encased EMT raceways. This section falls under Article 358, which covers electrical metallic tubing, commonly known as EMT. The NEC defines EMT as a thin-walled, unthreaded metallic raceway designed for the physical protection and routing of electrical conductors and cables. Section 358.12, titled Uses Not Permitted, lists the specific situations where EMT is not allowed to be used. One of the prohibited uses is where subject to severe physical damage. While this clause might seem open to interpretation, the NEC further clarifies that EMT is not permitted where encased in concrete or in direct contact with earth or in areas subject to severe corrosive influences unless made of corrosion-resistant material and protected by corrosion protection approved for the condition. This means that even if the EMT itself is made of a corrosion-resistant material, such as stainless steel or aluminum, the set screw couplings used to join the EMT sections are still a point of concern. As previously mentioned, set screw couplings are vulnerable to corrosion and loosening when exposed to moisture and pressure from the surrounding concrete. The NEC prohibition of set screw couplings in concrete encased raceways is based on years of experience and research that have demonstrated the potential hazards associated with their use. By requiring the use of more robust and reliable couplings, such as threaded or compression couplings, the NEC aims to minimize the risk of electrical failures and ensure the safety of people and property. Now, let's discuss the alternative coupling methods that are permitted for use in concrete encased EMT raceways. Firstly, Threaded couplings are a popular choice for creating a secure and durable connection. These couplings consist of two internally threaded fittings that are screwed onto the ends of the EMT sections. The threads provide a strong mechanical connection, and when properly tightened, they also create a good electrical bond. Threaded couplings are typically made of steel or aluminum and are available in various sizes to match the diameter of the EMT. When using threaded couplings, it's important to apply a thread lubricant or sealant to ensure a tight and watertight connection. This will help prevent corrosion and maintain the integrity of the raceway system. Secondly, compression couplings are another viable option for joining EMT sections in concrete. These couplings use a compression ring or gland to tightly grip the EMT, forming a seal that prevents moisture from entering the raceway. Compression couplings are typically made of steel or aluminum and are available in various designs, including set screw and threadless types. When installing compression couplings, it's crucial to follow the manufacturer's instructions carefully. The compression ring must be properly tightened to ensure a secure and watertight connection. Over-tightening can damage the EMT or the coupling, while under-tightening can result in a loose connection. In addition to threaded and compression couplings, there are also specialized concrete tight couplings available for use in concrete-encased raceways. These couplings are designed to provide a watertight seal that can withstand the pressure and moisture associated with concrete encasement. Concrete tight couplings typically feature a rubber gasket or O-ring that is compressed when the coupling is tightened, creating a barrier against moisture intrusion. When selecting a coupling for use in concrete, it's important to consider the specific requirements of the application. Factors to consider include the size and type of EMT, the depth of the concrete encasement, and the environmental conditions. It's also essential to ensure that the coupling is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or UL, or ETL Samco. This indicates that the coupling has been tested and certified to meet applicable safety standards. Furthermore, it's important to remember that the proper installation of electrical conduit in raceways is just as important as the selection of the right materials. Even the best couplings will not perform properly if they are not installed correctly. Always follow the NEC guidelines and the manufacturer's instructions when installing electrical conduit and raceways. This includes ensuring that the conduit is properly supported, that the couplings are tightened to the correct torque, and that the raceway system is properly grounded. By taking these precautions, you can help ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. To further clarify the point about grounding, it's important to understand that the metal conduit system itself often serves as the equipment grounding conductor. This means that it provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and de-energize the circuit in the event of a ground fault. If the conduit system is not properly grounded, a ground fault can create a dangerous shock hazard. Therefore, it's essential to ensure that all conduit sections are properly bonded together and that the system is connected to a grounding electrode system. The NEC provides specific requirements for grounding electrical conduit and raceways. These requirements vary depending on the type of system, the size of the conductors, and the grounding electrode system. It's important to consult the NEC and to follow its guidelines carefully to ensure that the system is properly grounded. In addition to grounding, it's also important to protect the electrical conduit and raceways from physical damage. Concrete is a relatively hard and abrasive material, and it can damage the conduit if it is not properly protected. To protect the conduit, it's recommended to use a layer of sand or other cushioning material between the conduit and the concrete. This will help to prevent the concrete from rubbing against the conduit and causing abrasion. It's also important to avoid sharp bends or kinks in the conduit, as these can weaken the conduit and make it more susceptible to damage. When bending conduit, use a proper conduit bender to ensure that the bend is smooth and gradual. Furthermore, it's important to protect the conduit from corrosion. Concrete can contain chemicals that can corrode metal conduit, especially if the concrete is exposed to moisture. To protect the conduit from corrosion, it's recommended to use a corrosion-resistant conduit material such as stainless steel or aluminum. Alternatively, you can use a non-metallic conduit such as PVC or fiberglass. If you are using a metallic conduit, it's important to apply a corrosion-resistant coating to the conduit before it is encased in concrete. There are various types of corrosion-resistant coatings available, including epoxy coatings, polyurethane coatings, and zinc coatings. When selecting a corrosion-resistant coating, it's important to choose one that is compatible with the conduit material and the concrete. In addition to protecting the conduit from physical damage and corrosion, it's also important to ensure that the conduit is properly supported. The NEC provides guidelines for the proper spacing and support of conduit runs. These guidelines vary depending on the size and type of conduit, the type of support, and the location of the conduit. It's important to follow the NEC guidelines carefully to ensure that the conduit is properly supported and that it will not sag or break under its own weight or the weight of the concrete. When supporting conduit in concrete, it's recommended to use concrete inserts or anchors. These inserts or anchors are embedded in the concrete and provide a secure point of attachment for the conduit supports. There are various types of concrete inserts and anchors available, including threaded inserts, expansion anchors, and chemical anchors. When selecting a concrete insert or anchor, it's important to choose one that is compatible with the concrete and the conduit support. In summary, the use of set screw couplings in concrete-encased EMT raceways is prohibited by the NEC due to the susceptibility to corrosion and loosening. Alternative coupling methods such as threaded couplings, compression couplings, and concrete-tight couplings are available for use in these applications. When installing electrical conduit in concrete, it's crucial to select the appropriate materials, follow the NEC guidelines, and adhere to the manufacturer's instructions. This will help ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. In addition to the points already discussed, there are a few other considerations to keep in mind when working with electrical conduit in concrete. Firstly, it's important to coordinate with other trades such as the concrete contractors to ensure that the conduit is installed in the correct location and at the correct depth. This will help to avoid conflicts and ensure that the concrete can be poured without damaging the conduit. Secondly, it's important to protect the ends of the conduit from damage during the concrete pour. Concrete can be abrasive and can damage the threads or the ends of the conduit. To protect the ends of the conduit, it's recommended to use conduit caps or plugs. These caps or plugs will prevent concrete from entering the conduit and damaging the threads or the ends. Thirdly, it's important to inspect the conduit after the concrete has been poured. Look for any signs of damage such as cracks, dents, or bends. If you find any damage, repair it immediately. This will help to prevent future problems and ensure that the electrical system is safe and reliable. Now, let's consider some practical examples of how these principles apply in real-world situations. Imagine you are installing electrical conduit in a concrete slab for a new commercial building. The conduit will be used to supply power to various lighting fixtures and receptacles. Because the conduit will be encased in concrete, you cannot use set screw couplings. Instead, you must use threaded couplings or compression couplings. You choose to use threaded couplings because they provide a strong and reliable connection. You apply a thread lubricant to the threads of the couplings to ensure a tight and watertight connection. You also use concrete inserts to support the conduit run. The inserts are embedded in the concrete and provide a secure point of attachment for the conduit supports. After the concrete has been poured, you inspect the conduit run for any signs of damage. You find a small crack in one of the couplings. You repair the crack immediately by replacing the coupling with a new one. By following these steps, you can ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. Now, let's consider another example. Imagine you are installing electrical conduit in a concrete wall for a new residential building. The conduit will be used to supply power to various outlets and switches. Because the conduit will be encased in concrete, you cannot use set screw couplings. Instead, you must use threaded couplings or compression couplings. You choose to use compression couplings because they are easy to install and provide a watertight connection. You follow the manufacturer's instructions carefully when installing the couplings. You also use concrete anchors to support the conduit run. The anchors are embedded in the concrete and provide a secure point of attachment for the conduit supports. After the concrete has been poured, you inspect the conduit run for any signs of damage. You find that one of the couplings is loose. You tighten the coupling immediately to ensure a secure connection. By following these steps, you can ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. These examples illustrate the importance of selecting the appropriate materials, following the NEC guidelines, and adhering to the manufacturer's instructions when installing electrical conduit in concrete. By taking these precautions, you can help ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. It's also important to stay up to date on the latest changes to the NEC. The NEC is revised every 3 years, and the changes can affect the way you install electrical conduit in concrete. By staying up to date on the latest changes, you can ensure that you are following the most current and accurate guidelines. You can stay up to date on the latest changes to the NEC by subscribing to a trade publication, attending a training seminar, or visiting the National Fire Protection Association, or NFPA, website. Finally, it's important to remember that electrical work can be dangerous. If you are not familiar with electrical codes and practices, it's best to hire a qualified electrician to perform the installation. This will help ensure that the work is done safely and in compliance with all applicable regulations. The information provided here is for educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Remember safety first.